All right, so today we're going to look at the Argand diagram. You'll find as you go through your maths, particularly when we get into higher level maths, that changing your perspective or the way that you look at a problem or the way you represent the problem can do huge amounts to solve it. And the Argand diagram is an example of a different way of expressing complex numbers that will help us solve a whole lot of problems. So what an Argand diagram is, it looks very much like a Cartesian plane, but it's just going to represent one number, and we're going to represent it, the real part along the x-axis and the imaginary part along the real. So if I have, let's say, a z that equals 2 plus I, well, that's 2 along the real, 1 up on the imaginary, so that's where my z is going to be. And maybe I've got a w, let's say that it's, I don't know, minus 2i. So it's minus 2 in each direction. Oh, minus 2 in each direction. So down here. I was intending, though, let's make another one. What should I use? Say a. I wanted minus 2 plus 2i just because it was going to be nicer. So that's my a. And then what happens now if I add these? So z plus a. Well, z plus a is going to be, those are going to cancel, so it's 0 plus 3i. 0 plus 3i. Now, if we thought about these as vectors, then in order to add on a, I would just be, going parallel or doing the other side. And you can see here that I've got to that point as if I thought about vectors. And that's really more to do with how adding and subtracting works than this. But sometimes it's useful to think about these as vectors. And we'll go more into that in year 12. But that's the basic idea, is we're representing a single number as a point on a plane, the real and the imaginary parts. Now, there's a few little interesting things. If we look at this z that I put here before, well, what is the conjugate of z? Well, the conjugate of z is going to be 2 minus I. 2 minus I is here. We've got a up here. What's the conjugate of a? Well, that's going to be minus 2 minus 2i. I guess it's, in this case, my w. Going to be here. What do we notice about these? Well, we notice that they're all reflections in this x plane, our real plane. And so that what the conjugate does is reflect us down, or if I did the conjugate w, I would end up back up here. So it just reflects it back over. Now, there's also interesting things happen when we multiply by complex numbers and see what happens. But I'm going to leave you to discover that as part of the assignment, not assignment, as part of your exercise today.